All right. So yesterday we briefly left off with, I think I can erase that, just writing down what those organic families are. So I don't have a whole lot for you today. There's a couple things I want to go through. Do you like hearing that? Oh, we don't have a whole lot to go over today. We're going to wrap up pretty soon. Could you not care less? It doesn't matter. Doesn't matter? Yeah. This person is going to be different. I just keep saying that out of habit more than anything else. And so after that, Looney Days 5K, we were extremely sore on Monday, Sunday. Not too bad. Not too bad. Okay. Everything hurts. This hurts. This hurts. My gastrocnemius is bellowing. Why would your gastrocnemius bellow? It's your calf muscle. Uh, 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 uh. Come on. That was funny. Not as good as the cheese. Oh. Okay. So again, we wrote this down yesterday, and we saw an example of alcohol. Okay. Which one of these organic families do you think used to be utilized as an anesthesia? In other words, one of them things to where inhale it and is it an alcohol, an ester, an ether, an acid, a ketone, or an amine? It's just a guess. There's no. What's that? Was that a guess? Yeah. That is correct. Okay. It used to be that doctors or nurses would take I don't have a cloth rag. This is the best I could do. A pure compound of ether, put it in a rag, put it over their mouth, so as the patient would inhale that, they would slowly lose consciousness, and then be able to, per se, have a woman go through childbirth or do something like minor types of surgeries. Because I know some of you have had your wisdom teeth taken out. I know there that I know of, and some of you may have. I just don't know. And anybody else, their wisdom teeth are gone. All four. So you probably said it wasn't even a knock me out. I don't even want to be awake for that. That would be my guess. For some reason, all four of mine should come out too, but just the top two came out. The bottom two, there's a branch off of that facial nerve that is wrapped around one of those roots. And the surgeon looked at some sort of X-ray with that, said we made some not a mistake, but depending upon how that's wrapped around that root, you do damage. You could have a drooping face like this. It'll be permanent. So as long as they're not bothering you, we'll just leave them in there. So I just took Novocaine on the top. Of course, didn't feel that. But would the sound bother you? Because you can hear the pliers on the tooth going scrape, 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 and finally hear it come out. Or would you still say, knock me? I don't even want to be conscious for that. Okay. And one of the aspects that we notice is now we call it anesthesia. Okay, and this was just the first form. It's a type of gas that just causes you to lose consciousness. Okay. Let's see. We want to show you what a molecular formula is. We've been doing that this whole time, but To me, you're always going to be better off. You don't have to, but utilize this one instead. Okay? You don't have to, but when we get into some of those organic reactions, it's just perhaps beneficial to always use the structural formula rather than the molecular. Oh. General chemistry, maybe I had to individually. I was like, say that 3 times. Right? Salicylic. Just salicylic. Yeah. I don't know if I salicylic. It sounds. I sound dumber, probably not, than as it sounds better than best the first time as you go. Where's the Kennedy heard this? Because your mom probably got that joke, because it's a good one. Okay, I'll tell you. Okay. This gentleman goes into the pharmacy, talks to the pharmacist, and he says, I need some acetylsalicylic acid. Oh, you mean aspirin? Oh, that's right. I can never remember the name aspirin. He can remember salicylic acid. Yeah. Okay, I'll wait till you get off the floor rolling. I still think that is so funny. Okay, so we're done writing, and now I noticed on the first day a lot of you had a notebook, and that's a very good idea. That when we are writing some of these materials down, I would highly, highly suggest that you do the same. Okay, so what we mean by this is, okay, if we're talking about ethanol, okay. Okay, and this, for example, is a good reason on why you may want to always write the structural formula. Because I told you the top one was ethanol, but that bottom one, that could very well be dimethyl ether. You don't know until you write the structure out. Okay, so remember these are molecular formulas because it tells you the elements and the number of the atoms that are in that element or in that compound. Okay, so if this is the molecular formula, well then we will change that to the structural formula. So we've got 2 carbons. This is what you're more familiar with. Okay, there's your 2 carbons. Okay, we've got 5 hydrogens, 1, 2, 3, 4, 5, and then we've got this OH out here on the end. We've accounted for everything. Okay, molecular formula, structural formula. So how do we know that that is an alcohol? It's an organic family. How do we know this is an alcohol? Because it has an OH on the end. That's correct. Okay. Now, if we look at this compound from this molecular formula, you'd say, well, what about if we did this? Okay. 2 carbons, there they are. 1 oxygen, there it is. We got 5 and 6 hydrogens. We got 3 and 6. Okay. So for various reasons, it's probably always a better idea if you can write the molecular, or excuse me, the structural formula rather than the molecular. So what is that? That would be dimethyl ether. So we're not going to name these right now. We just want to show you the difference of these organic families. We know this is an alcohol because what we could say is, all right, X marks the spot. What's branching off of that carbon? An OH group. Okay. What do we see here? X marks the spot here and here. We've got an oxygen that's single bonded between two carbons, making that an ether. Okay. Alcohol on top, ether on the bottom. Now, going in order, alcohols was the first one. And then, let's see here, ethers, so we've seen that. Oh, excuse me, esters would be the next one. Okay. So, let's go ahead and just write out what an ester would look like. Just wondering what, I think this one will probably show up all right. Down here. Okay. Yeah, it's showing up on the board. Okay. This one, that one. Now we've got an ester up on the board. So, note, what do we see that's similar with what's written in the green as opposed to this red, maroon, purple, or whatever this is? What do they have in common? Okay, what's in common about the oxygen between these two organic compounds? Yes, it's in the middle. And how is that oxygen in that parent chain bonded? It's single bonded, okay? So what we're looking at here is between these two carbons, we've got just a single bonded oxygen, just like an ether has a single bonded oxygen, just like this ester, but the ester stands out because how? How is that ester different than ether? It has a double bonded oxygen. So in this case, if we say X marks the spot here on this carbon, it's got a double bonded oxygen and a single bonded oxygen at the same time. And one of the things to note, are we missing a hydrogen down here? You're shaking your head no. Why are you right? Yeah, because carbon can only have 4 bonds, 1, 2, 3, and 4. Oxygen can only have 2, 1 and 2, and the rest of these carbons can only have 4. And just as a quick review, why is oxygen only having 2 bonds? Well, what column is oxygen in? The 6th. So how many more electrons does it want to gain from what you learned last year? 2. So if it wants to gain 2 more electrons, that's why it has only 2 bonds to it. And it can also double bond, as you can see. Okay. One more, and then we'll. This is an ester. Okay, so kind of crossing these off as we go here. All right. So now do this up and over here. I think it's up on the board. Yeah. Okay. Okay. that is an acid now. Okay, now we've accounted for him. So what does this, when you're done writing this, I don't know how long it takes you to do that. If I'm standing in the way, it probably takes a little longer. Okay. Does this acid have anything in common with any of these other structural formulas? Yep, yes it does. And anything else though? You're right, but what else? A double bonded oxygen. Right. So this organic acid, okay, it has an OH at the end, just like an alcohol does, but it also has a double bonded oxygen, just like this compound, which is called a what? Ester. Yep. And this one also starts with an E, but it is a what? Right? So we could say X marks the spot here. Okay. It's got a double bonded oxygen and an OH group. Okay. And that makes this an organic acid. You know, out of these four compounds, this one I probably like the least. I don't like it either. But it wasn't. Some of you laugh. Maybe it's not funny. All right. Come on, it's Friday. We can be happy, people. All right, fair enough. So, like I said, we're going to try to keep it short. I think that's a good place to stop for today. Next week, okay, we will continue talking about these organic families and then start talking about saturated hydrocarbons. Okay? And the reason we don't have anything here that we consider a saturated hydrocarbon, because remember when we say hydrocarbons, it only has hydrogen and carbon. These have different organic families. We don't have any alkanes, alkenes, or alkynes up here. These are, again, we're classifying these organic families. All right, so we will catch up to you on Monday and continue moving forward. All right.